Okay, so let me read again. So we're doing now section 7.3 when sigma is not known. The amount of water consumed per week by Montana residents is normally distributed with a known mean. A simple random sample of 26 residents. What's 26, guys?
N.
N. Don't be afraid of saying N because it is indeed N. You make it something else, you ruin the entire problem. It is N. Has a mean value of 120.3 gallons. What is this? That's a sample mean, X bar. Just the word mean, guys, the word average should be an indicator for you that this is X bar.
I think it was just tricky because it said unknown mean.
Oh, well, usually the population mean is unknown. We're just trying to study it. We're trying to study whether the mean is bigger than something or less than. We don't know what the actual mean. We will never know. So it is a true statement. Unknown mean, unknown population mean. But the 120.3 gallons is the known sample mean. So we know the sample, guys, but we know nothing about the population. We don't know what the population mean is. And a standard deviation of 10 gallons. He didn't say it is a population standard deviation. He's talking about, look, he started his statement with a simple random sample has a mean and a standard deviation, so that must be S. That's a big difference between the two sections, guys. Now it is S now, 10 gallons. The city of Bozeman claims that the average water consumed in the state of Montana is not 125. Who's going to help me write the null in the alternative? Actually, guys, I'm going to give you a minute to write the null in the alternative. Here you go. Because sigma is not known, guys, we're going to use the t distribution, which requires degrees of freedom, as I explained to you in chapter 6 when I showed you the t distribution. So it will be a t-test, guys. Is not given, but S is given instead. S is the sample standard deviation. All right. The formula, guys, will be X bar, if you want to see the formula, minus mean, same thing as Z, but instead of sigma, we put S over square root of N. That's the formula. I'm going to show you that this formula works, but we're going to go to the calculator right away and run this test and watch how easy it is. It will be easy when you state step number 1 correctly, and when you know how to identify those numbers. It will be a very, very easy test, guys. So you go to stat. You see it's number 2. Take a note. T-test. Okay, mu0. Mu0 is the value from the null hypothesis that you assume it is true until proven otherwise. So it's 125. X bar is 120.3. S is 10. N is 26. And we choose not equal to. Look, make sure to select it, guys. And if you want to see a draw, I like to see a drawing of the p-value. Oh, it's a small p-value. There you go. T is usually T to 3 decimal places. He will tell you when you do your work online, he will tell you what the system will tell you how many decimals. Just follow it. So it's negative 2.3. Okay, it's going to be negative 2.4. 0. And the p-value 0.0244. Okay, he says sketch it. Let me sketch and show you the p-value. Well, you already sketched that on the screen of the calculator. Put T here, don't put Z, guys. So we're not doing the Z line anymore. And this is the p-value, something on the left and on the right. I mean, I'm shading too much, but just to make the visual. And this is the p-value right here. 0.0244. Any questions so far? Okay, tell me what's your decision, guys, at the alpha equals 0.01. Do you reject HO or fail to reject HO? This is a p-value. Is the p-value bigger than alpha or less than alpha? If it is less than alpha, you reject. If it is bigger than alpha, you fail to reject HO. So what do you say here? This is comparing numbers, guys, just comparing numbers. Yes? Is 0.0244 greater than 0.01 or less than 0.01?
It's greater.
Greater than alpha. If it is greater, guys, you must fail to reject HO. All right, next step. Okay, I'm gonna show you how I'm gonna follow my notes about 4 scenarios and show you that it does work. Since it is failed to reject HO, guys, I told you, you start with there is not. Enough evidence at the 0.01 level of significance. Okay. 2. Now my math lab is asking me to select to support or to reject. It will change the entire problem if you select the wrong word. Okay, this is what I've been telling you guys. Where is the claim? The claim is in HA, then you use the word support here. So there is not enough evidence at the 0.01 level of significance to support the claim by the city of Bosman. And what do they say? You just copy it, guys. Copy it and paste it, that the average water consumed is different from uh, 125 gallons. We cannot support their claim. So maybe their claim is not valid, guys. That's what we concluded. Any questions? Okay, let's do this next question together. What I wanted to show you guys, had you put here X bar, which is 120.3, minus the mean, which is you get it from the null, 125, and had you divided by S, which is 10, over the square root of 26, you would have gotten, just negative 2.40. So that's what's programmed into the calculator. This formula is programmed into the calculator, guys. Okay, let's do number 3. Step by step. A credit card company wondered whether giving frequent flyer miles for every purchase would increase card usage. So they want people to increase, use their card, very often, and they want to throw in frequent flyer miles, which has a current mean of 2,500 per year. So the usage of the card is on average $2,500 per year. They gave free miles to a simple random sample of 24. So would you guys agree with me if I put N is 24? And found that the sample mean to be 2,542. There is no debate, guys, that this is X bar. It says sample mean. With the sample standard deviation, there is no debate that this is S. He says it's sample standard deviation. S is 109. So you know it's a t-test. State the null and the alternative. What's their intention? They want to increase. A credit card company wondered whether giving frequent forever would increase card usage. What does increase mean, guys, in terms of inequalities? Yeah, you are correct. Greater than. They want to increase, so they want people to spend more than $2,500. So it will be this, guys. You state HA first, which is the mean bigger than 2,500. That's what the company is claiming. They're claiming that hoping if they increase, they provide the frequent flyer miles incentives, that people will spend more than 2,500 on average a year. And what is HO? It will be the opposite statement. This is why I like to absorb, guys. I like to absorb how we're stating those null and the alternative hypotheses. Okay, it's a t-test. Let's do the t-test together. And you're gonna see it's a piece of cake once you state the first step. Step tests, t-test. All right. Mu 0 against 2,500. X bar 2,542. S, what was the standard deviation? 109. N, how many? 24. Okay, and can someone tell me which sign do I use, first, second, or third? Now, before the last step. Greater than, yes, I agree. So make sure, guys, any questions, please let me know. I'll go back and explain it. It's very important that you comprehend. I'm gonna do calculate this time rather than draw. Okay. T is 1.888 to 3 decimal places. And the p-value, I said find the p-value or critical value. I haven't talked about the critical value, so just p-value. 4 decimal places, guys, so it will be 0.0359. All right. Make a decision at alpha equals 0.01. Does everyone agree that the p-value is what, guys? More than alpha or less than alpha? I have a 3% here and I have a 1% alpha. So what is that? Greater or less than? Yes?
Greater.
Greater, definitely. And if a p-value is more than alpha, you fail to reject HO. And if you fail to reject HO, guys, you start with there is not. Anytime you have a fail, you put there is not enough evidence. I'll move this up. There is not enough evidence at the 1% level of significance to, okay, what's the magic word, guys? Support or reject? Where is the claim? In HA. So what word do we use when the claim is in HA?
Support.
Support. Please don't forget that. That's very, very important. We're not saying that we're supporting, we're saying that there is not enough evidence to support. So saying we're not supporting, but you have to use the word support. And when I don't support something, it doesn't mean I reject it. I just don't have enough evidence to support it. That's all I'm saying. So to support the claim by the credit card company. That means the credit card company should go back and revise their offer. It's not working. They're giving incentives to people to increase usage of their credit card, but people are not using it as much. So probably they should discontinue this program. This is what you can conclude of it. It's very serious studies that you do here, guys. And if you do it right, then people, just are bound by the results, just of their of your study. They have to accept them. Okay, so that's number 3. Okay, we'll do one more and take a break. Number 4. As I told you, it's a very important section. I have quite a bit of questions here on this section. Okay, let's get ready for number 4. A fast food outlet claims that the mean waiting time in line is less than 3.5 minutes. Now it's clear, guys. He gives you the sign. He tells you what the sign is. Just write down the null and the alternative hypothesis.